Hey there taggers, we are up to some awesome stuff again. Today, we are diving into Blender 4.5's one of the new geometry nodes, the Camera Info node. The new Camera Info node offers a ton of new features and in-depth control over our camera. So, let's dive right in. Let's take a look at the inputs and outputs of this node. The node gives us only one input, which is of the object type. Naturally, we must connect a camera object to it to correctly read its data. I would have expected a warning on the node if we connected a mesh object, but I assume this will be fixed later. We can expose this object input to control it from outside the node. Or we can simply connect the active camera node and use it instead. Moving on to the outputs. The first one we see is the projection matrix. Basically, this is a 4x4 matrix that holds all of your camera's key settings, like the focal length, sensor size, shift, and clipping range. It's super useful, because it can take 3D coordinates from your scene and project them directly onto your 2D screen. This output is incredibly useful for optimization, especially for Frustum Culling in physics engines and render setups. The Frustum Culling setup shown here is available for totally free. You can download it from the link I gave in the description. And focal length. This output gives us the current focal length value of the active camera in the scene. This value is in millimeters and indicates how zoomed in the camera is. A higher value means the camera acts like a telephoto lens, while a lower value acts like a wider angle lens. We can use this value to create dynamic change in our geometry based on how much the camera is zoomed in or out. We can read our camera's focal length value with this output and manipulate our objects as we wish based on this value. This way, when we animate the focal length, our objects will be driven accordingly. We will both have manipulated our objects and be able to achieve more artistic results based on the change in our focal length. The sensor output gives us our sensor values from the camera menu. By animating this value as well and then reading it through the output, we can manipulate our objects in the same way. This value is a 2D vector, with the X component representing the sensor's width and the Y component representing its height. The shift output is also a 2D vector that tells us the horizontal and vertical shift of our camera's view. Think of it like this. You can move the camera's frame of view left, right, up or down without actually moving the camera itself. The X value controls the horizontal shift and the Y value controls the vertical shift. This is really useful for things like architectural shots, where you can keep your camera level to avoid perspective distortion and just shift the view to capture the full building. The clip start and clip end output gives us the minimum and maximum visibility distances of our camera. The clip start value is the minimum distance an object must be from the camera to be visible. Anything closer than this will be clipped and won't be rendered. The clip end value is the maximum distance an object can be from the camera to be visible. Anything farther than this will also be clipped. Think of these two values as a slicing tool for your scene. They define a visible range or frustum, and anything outside of that range is ignored. Imagine you have a large landscape filled with grass particles. You can use a geometry proximity node to measure the distance of each grass particle to the camera. Then, using the clip start and clip end outputs, you can set up a system to only spawn grass particles within the camera's visible range and delete them as they move out of it. This is a powerful optimization technique because it ensures you're only rendering the geometry that the camera can actually see. The focus distance output gives us the focus distance of our camera. In other words, it's the value that determines which distance in the scene will be perfectly in focus. This value becomes visible and adjustable when you enable the depth of field feature under the camera settings in Blender. Using this output, you can create a dynamic system that determines which objects in our scene are sharp or blurry based on their distance from the camera. This is a great way to draw the viewer's attention to the objects in the sharp focus area. The is orthographic output is a simple but powerful Boolean value. It returns a true or false value depending on your camera's projection type. It will be true if your camera is set to orthographic mode. It will be false if your camera is set to perspective mode. This output is incredibly useful for creating dynamic setup that automatically change based on the camera's projection. The orthographic scale output gives us the scale value of our camera when it is in orthographic mode. This is the zoom level of an orthographic camera. As this value increases, the camera takes in more of the scene and appears to zoom out. As this value decreases, the camera takes in less of the scene and appears to zoom in. Simply put, the orthographic scale is the orthographic equivalent of the focal length value for a perspective camera. You can use this output to create dynamic effects that change based on the orthographic camera's zoom level during an animation or visualization. Now, to wrap things up, we have seen how the camera info node is an incredibly powerful tool. It's essentially our bridge between the camera's properties and our procedural workflows in GeometryNodes. By simply reading a single value, whether it's the focal length, sensor size, or the focus distance, we can create complex and dynamic effects. We can build systems that automatically react to camera's change, optimize our scenes with Frustum Culling, or create artistic effects where objects change color or size based on their relationship to the camera. This node gives us a new level of control and creativity, allowing our procedural setups to become fully integrated with the camera itself. I encourage you all to experiment with these outputs and see what amazing things you can build. By the way, if you are looking to learn GeometryNodes from A to Z, mastering every single node along with practical use cases and pro tips, you should definitely check out my Udemy course. It's packed with enhanced information and awesome graphics. And for you, my amazing viewers, I have prepared a mega discount. If you want this resource to be a permanent part of your library and add significant value to your career and CV with a lifetime certificate, you can access the course using the discount code or through the link in the video description. And a huge shout out to all of you amazing taggers who stuck around until the very end of the video. You guys are the best, seriously. If you wanna see more content like this, all you gotta do is hit that like button and subscribe to the channel. And I'd absolutely love to read your thoughts in the comment section below. Until the next time, hasta luego.